So, thank you, Pradeep. I think a few years ago, everybody used to think about, hey, GPUs are in shortage. And that's because if you think of Nvidia, there's a supply chain behind us, TSMC and others. And we, of course, get gated by processes at TSMC and so on. But you should also understand there is a supply chain in front of us, where even if we produce enough GPUs out there, ultimately, for you to run a model, you need data center power and space and capacity and all that. And that could be a real constraint. And so that is actually the biggest constraint that we are dealing with. So Pradeep, you framed energy as the first thing, for example, in your 5-layer cake. Energy is a huge constraint for us right now. And so, and that's the reason you are seeing, like, say, companies like T-World do well, because we are trying to unlock that, what we call land power shell, right? So it's a key ingredient in the downstream supply chain that has to be unlocked. Because basically AI is about turning data into intelligence. You cannot do that with energy, and there is only so much energy that is out there. And so wherever you can unlock that's one way you can think of determining the winners of the thing. If you look at the next layer up, which is the chip layer, this is where Nvidia's bread and butter business is. So the simplest way you can think about it is, ultimately in this new economy, it's about the cost per token, but it's also about the tokens that you can produce within the energy envelope that you have. And so whoever does that well, not just with chips, but with the software capabilities around it, by bringing all the other ingredients of the infrastructure, which I'm sure later we'll talk about it. So that is also a basis for that winners in this race. So that's the second layer. And then the third layer, the infrastructure layer, the way I think about it is, you essentially are creating that infrastructure either on-prem or in the cloud. But typically, traditionally we have thought about clouds as AWS, Google, and so on. But going back to this constraint, whoever can unlock this data center power and capacity has the opportunity to be a cloud provider. That's why we see CoreWeave emerging, DBS has emerged, Nscale has emerged in Europe, and so on. So that would be another category where winners will emerge in this race. So there's money to be made in all layers of the stack, like how we're talking about the bottom three. So this is one way I would frame it for you.
Thank you, Yogesh. And maybe I think that's a good, maybe my follow-up question to you really is like, the Yogesh really talked about 3 layers. You have a lot of hyperscalers in this stack. So what do you think about these 3 layers?
Yeah, thank you, Pradeep and Yogesh. Thank you for giving the big picture. Land power shell is super important, and then comes energy. That is a very big constraint. I think everybody is seeing that, it's in the news. And then how do you take this energy and what sort of engines convert that into tokens and intelligence? And that's where your point about the chip layer comes, that's the 5 layers there. And when I think about the chip layers, to me that means, think of the integrated platform from Nvidia, the Vera Rubin, which is powering the next generation of agentic AI. So agents need to be able to reason, plan through multiple workflows, and that's where Vera Rubin platform, which has 72 GPUs and 36 CPUs, brings all of our advancements in chips together. So if you think about it, there is 7 very advanced chips, CPU, GPU, there is our NIC, the Spectrum switch, the NVLink switch, also the LPU ROC for inference. So think about all of these technologies along with the software, the CUDA libraries, security, all of it is coming together. It is not being treated as like separate layers. So we are doing extreme co-design. And by that I mean, again, that bringing all of these technologies together, working, co-designing, along with the software, all of these chips, and making sure they can work in as one compute in one rack. And then these racks scale. And this is the foundation for the AI factories that we're building. And to your point, Yogesh, you were talking about like, hey, we're going to be bringing all of these agents for having a lot of, I was at Google Next conference a week ago, and there was a lot of talk about agents, future of agents. So think of Bear Ribbon as one unit of compute and all these technologies coming together. And with this extreme co-design, I guess the point is that you are able to, for example, reduce the token inference cost by 10x compared to the Blackwell generation.
Yeah, I think the extreme co-design is such an important point here. But I think let's also understand, like sort of you deal a lot with the edge, and how do you see these chips and the infrastructure for like the edge kind of use cases.
Yeah, definitely. I mean, I cannot overemphasize the need for extreme co-design in data centers, because we all know token cost is super important. Needing to operate the entire data center, not just chips and racks, at the best operating point is super, super important. Comes with power, cooling, software. But to Pradeep's question, when AI started, it started in the cloud, and it made sense because models were big, models are still big, and it unlocked so much productivity in consumer and enterprises. It's unprecedented. It's once in a lifetime opportunity. But what we also believe at Nvidia is the next wave of AI transformation is going to come in physical spaces around us. Physical spaces in the form of physical AI. Could be robots, could be automation systems, could be your infrastructure that itself operates as a robot. And sometimes for that AI to function, you need to be closer to the edge, simply because of low latency, or simply because of data sovereignty, or simply because the sheer bandwidth of sensors that you can process is so high that you want to be right there. So we do a lot of great work in creating these platforms at the far edge. We have a Jetson family of products. Thor is the flagship of it. We have Spark platforms. But the challenge when you think about edge and the next wave of applications that are starting to spiral up, the limitation that edge brings is it's fixed. It's fixed in terms of its deployment, its infrastructure. What cloud offered was elasticity, scalability. When there was more demand, you could scale up. When there was less demand, you could scale down. You don't have that much flexibility at the edge. So we're starting to think about an entire continuum from edge to cloud as we think about infrastructure. And potentially, you can imagine telcos being the middle ground where they can offer the same benefits of low latency and localization and data sovereignty, but at the same time offering elastic compute. You can scale up and down your compute as your workload grows. So it doesn't mean the far edge goes away. Robots will always need computers in the robots. It's just too low latency of a workload. But then, as the workload stretches a little bit, where you need to be still closer to the edge, but not quite dealing with the cloud, telcos is a great place to drop this compute. So that's my thinking about infrastructure. It's a continuum from edge to cloud, and it will need an entire ecosystem of software, security companies, orchestration companies, enterprises, and even governments to come together to realize this vision. It's not a single company play.
Yeah, no, thank you, Saurabh. And I know Yogesh really wanted to make a point before I go to Shilpa. So
I
Yogesh.
just want to make a very quick point. I want to connect it to the land power cell constraint that I talked about. Think about it, current AI factories that are getting built, they're centralized. But telcos also have point of presence. So if they can extend, like basically this, using their point of presence, right, where there is excess capacity that is sitting with lower latency capabilities, and if you can connect all of that into an AI grid, you are unlocking that energy and the data center space for the market, which it absolutely needs, because without that, the world wants to do more AI than it's able to do today. So if a telco can unlock that, that's powerful, right? That's
No, I think, thank you, Yogesh. And maybe there is another very, a different perspective is how we are thinking this from a sovereignty perspective, and like all these three layers, and that's why Shilpa.
Yeah, and look, we all know there's a little bit of geopolitical situations happening all over the world these days, right? So countries and companies are looking to have some level of resilience, some level of self-reliance in thinking how they're building out their AI. So sovereignty, that's the word for how much control you have over your own infrastructure, over your own AI, is become very important. And that is why we are seeing governments trying to create a kind of ownership of AI data centers that they can own and control. But I want to point out that sovereignty is not about silos. It's about collaborating, and it is about owning what matters and leveraging what's proven. So that's an important nuance there, and that's why you see a lot of partnerships that are being formed, allied partnerships between allied nations. And the whole aspect of economies and the GDP is tied to AI. It is token economics, right? So earlier it was productivity was measured in the form of labor and capital, but now it is labor and capital and intelligence or tokens. So you must have seen Sam tweet a few months back that guys stop using please and thank you when you're using your favorite model, because that consumes tokens and that consumes energy. Energy is the biggest constraint. And that's why players from utilities, telcos, regional clouds, they have become a very important entity in creating these national sovereign data centers, national sovereign AI clouds. We are seeing telcos coming up as those regional AI cloud providers because they have the reach, they have data centers which they are now transforming into AI data centers. Countries are not only putting in their AI strategies in place, but their energy strategy, very important. That goes hand in hand.
Yeah, no, thank you, Shilpa. I think the first three layers, as like all of my panelists here talked about, I think it's super important to really think through energy, chips, and the infrastructure, think from cloud to edge, think from the sovereignty perspective, think about like how all these pieces are coming together. But I think that's a good time for me to move to my fourth layer, which is super important, which is models, right? There is a great trend, as all of you know, is moving. Like we all started with some of the frontier models, but a lot of these frontier models are now also becoming like the open source. Right? So I would love to hear your perspective. Maybe we'll start with you, here. What do you think about where open models are? How do you think the strategy of these open models is actually helping all the enterprises, helping all the industry in really adoption of this AI?
Yeah, happy to. So, if you first of all, let's look at building a model with frontier capability is a ton of investment. It's billions and billions of dollars of investment. Now, there are of course closed frontier models that are available. ChatGPT is an example of that. Anthropic is an example of that, and so on. China has, of course, built some open models, right? DeepSeek, Kimi-K2, and so on. So that's one dimension. The second dimension that you have to look at it from the perspective of an enterprise. An enterprise does not want to make that billions of dollars of investment that I just talked about. What they would like is some starting point to which they want to bring their proprietary data so that they can have a foundational layer of intelligence on top of which they can build it. Think of a bank, for example. Banks operated on paper, then they operated on data, but now their solutions could be credit risk assessment, customer care, it could be transaction fraud management, and so on. But they want to have a base layer of intelligence which should be built by taking some model to which you bring proprietary data. But who is going to provide that sustainable path with billions of dollars of investment for enterprises to go do that? This is a core part of Nvidia's strategy going forward. We are essentially saying we will step up to that. We will make that long-term, sustainable, committed investment towards open models. So what does that mean? It's not just in the area of text or images or so on. Nemotron is our model for agentic AI, for example. We have announced open model in self-driving vehicles called Alpamayo, where you can look at the feeds from cameras and the voice commands that are coming in and determine the future trajectory of vehicles. We have open models in climate. We have open models in robotics. We have open models in physical AI. We just announced an open model in Quanta. It's a very, very big part of our strategy. And the reason is what I just said. We want enterprises to be able to grow with AI, and they need a starting point for that intelligence space.
Yeah, I think open models are becoming such a critical part of life because every enterprise would like to take them, fine-tune them, right? Based on their local data. I think that's the key point you mentioned. But Renu, I would also love to hear your perspective. You work with a lot of hyperscale, and they all have their life models, right? And there is also this open models. How do you see
Yeah, so I certainly think that the open models are being used by enterprises. They want to take these models, fine-tune them, bring their own data, and basically they want to sustain their investment and adapt over time. So one of the examples that I was going to bring up was that I was in Las Vegas and happened to go to Puma's biggest store right there on Las Vegas Boulevard. And there is a AI concierge agent. So they just launched it a week ago. If you're going to be heading out to Vegas this weekend, go check it out. You can actually stand in front of the agent, and it's multilingual. So I tried both Hindi and Punjabi. I think it works. Okay, somebody was talking in other languages too. It's multilingual, and it's built on our Nvidia Nemotron models. So the Nemotron models and Nemo Toolkit, these are available anywhere. Like you can get them from any hyperscaler, any cloud. You can use them on-prem. So that's the beauty of open models. They're easier, you can bring your own data. In this case, Puma can sustain and adapt. They have live inventory blocks. And so you can evolve. You have some control over that. And of course, also starting to see, for example, on the startup side, like CodeRabbit and Factory AI, using for code editing and PR analysis, they're also built because they couldn't make all the investments and resources that were needed. They started with open models as well. So that's an area where, again, Nemotron and Nemo Toolkit is used. If you look at enterprises like CrowdStrike, they're building a security operating center where the agents are going to be working side by side with analysts and looking at threats, issues, and proposing solutions. All of that, again, built on open models from Nvidia and the Nemotron models, which are easy to deploy. They're, again, available on cloud, on-prem.
Yeah. So, I think a couple of key takeaways in the models here is like, the world is going to have both, right? We are going to have frontier models, which is like maybe closed source, and there are good reasons for them to exist, right? And there will be enterprises who will have a reason or need for them to adopt. But there is also a very good reason why the entire open source community will keep on driving the open source model. And these open source models, like Nemotron, as we talked about, are also pretty much very close to the frontier models' performance, accuracy, and the reliability of these models. So this is how this layer is evolving. I think the things are changing almost every day, and this is something in a very interesting area. I will highly encourage all of you to keep on looking into that. Every week there is something new. But with that, let me change a little bit my gears and go to my last layer, which is applications. As all of you know, coming from the industry, most of the monetization happens at the application, right? So it becomes super important that everything which we build up in these 4 layers, somewhere the end phase where monetization is happening. And there are 2 parts. Like one is all industries or enterprises that you can see, from financial services to retail to manufacturing, like healthcare, automotive, there are so many industries. And another area which is like, as we see, like physical AI, which is coming up, and everything which is moving today will be autonomous and agentic, right? Every physical space which you see will have an impact of AI. So to little bit touch upon that, let me ask you, Saurabh, because you work a lot in physical AI space. How do you see this, the 5th layer, the monetization part, and how all these 4 pieces coming together, which is really driving the applications in your space?
Yeah, thanks, Pradeep. Before I go into physical AI, I should probably concur with Renu here that we're already seeing, enterprise deployments of agents and and then generating measurable ROI at this point. So it's not a future thing, it's the present thing. Now the future thing is where our physical spaces have AI infiltrating everywhere, right? In the form of robots, like I said, or in the form of helping us do shopping, or in the form of packaging and shipping and you name it. The challenge with physical AI, compared to what we've been seeing in the last, the frontier models that we've talked about, is physical AI models have to be extremely accurate all the time. It's like a self-driving car. You cannot afford to go wrong at any single point in time. You have to be very repeatable, and you have to be very reliable. And to make it so, you need data. Without data, you cannot get to that point, simply. The challenge with physical AI data has been, you cannot scrape the internet. There's just nothing on the internet. There's nothing on Reddit, there's nothing on X. So what do? And this is where the last, I would say, year and a half have been phenomenal. A lot of things have happened, but two things that I would explicitly call upon that will help us realize this vision. One is our ability to generate data, because you simply can't collect enough data and label enough data, so it's best to generate data. And then this physical AIs need to be tested. So before you put them into production, it's hard to recreate a real world and test them. It's a super expensive proposition. It's a super risky proposition. So being able to create digital twins of your spaces and then test these models, those are the two fundamental foundational technologies that have matured. We've been working on these for about 10 years or more than 10 years now, and it took a very long time. On the data creation part, we've all heard about diffusion models and their evolution, being able to create data at a simple prompt. That has started to become very, very reliable. And then on the simulation side, technologies like Omniverse with physics accurate digital twins and the ability to run physics accurate simulation, I think is absolutely transformative. So in terms of the application space, I think we're at this inflection point where all the right ingredients are falling into their sockets, and the next gen of physical AI applications on this continuum of infrastructure, distributed infrastructure, should start to arrive in mainstream.
Thank you, Saurabh. I think all this physical AI, we say like 3 computer problem, like training, deployment, and simulation, right? So, but Shilpa, why don't we move to you and you talk about?
Yeah, I mean, it has certainly, AI has moved from experimentation into actual applications, and ROI applications is where the value is realized. From a sovereign perspective, I'm starting to see startups and industries and companies within nations wanting to retain the value that's being created from AI for themselves. Basically, when you make an API call based on a frontier model, that value actually goes overseas, right? There's a certain amount of leak that happens. Now, countries want to keep all of that value, or majority of that value within the nation, which is an opportunity, a huge opportunity. There's a report which says that $15 trillion is going to be unlocked by AI. But the way it stands right now is that only 20% of the world's companies are capturing up to 70% of this value. So there is a huge opportunity, pretty disproportionate the way it is right now, but it's also a great opportunity for startups, for enterprises to capture that, to localize those large language models with your own data sets, fine-tune them to your own language, so that it represents the nuances of that country, right, or of that company, make domain-specific models, and create applications on that. And we have started to see a few examples in pockets around the world. A good one is from India itself, actually, where Bharat Gen, one of the models from IITs, is now being adopted by, it's called Krishi AI, it's for farmers, and it works in 22 different languages, Indian official languages. And what used to be a very scarce knowledge accessible only to a few is now at the fingertips of all the farmers. Right? This is how you democratize AI. And now that has now converted into actual ROI, where farmers have that power of determining their yields or what types of pesticides, even getting early access to subsidies that governments and their states are making available to these farmers.
Yeah, and I think that's a very important point that this year, like even it started even the last year, there's a lot of applications which are actually moving into the production, right? Coding is a great example, like which is kind of completely agentic, that's the way it's moving. So with that, let me, what I'm going to do is I'm going to do a little bit of rapid fire questions. So I will have one question and I will have one of you answer that. You have to be very quick. Okay, so let me start with...
Is there a hamper at the end?
Probably that's a good question to organize, huh? But let me start with my first question. Building your model or fine-tune frontier open model?
Maybe I can take that.
Okay.
Because it's the easiest of it. Everybody has explained it enough times over. I think definitely fine-tuning an open frontier model is the way to go. The value is going to be in the data that you can create, and your enterprise data, your proprietary data, and this way that model becomes a part of your organization. So definitely I would lean on fine-tuning it.
Yeah, thank you, sir. Second question. Talk a little bit about token economics. Who would like to take it? Okay, Shilpa,
Okay,
you
yeah.
take it.
Token economics is the new way of the world. GDPs are tied to that, so think about creating your own AI factories to produce tokens at the most efficient and cost-productive way.
Okay. My next question, what do you think everyone in the audience should think about, open cloud, the most popular term of this year?
Okay, I can. I'll relate it to your top layer when you guys are talking about applications. See, the top layer, I don't just think applications, I'm essentially thinking unlocking the value in enterprises based on all the 4 layers that are down there. And so, open cloud, think inside an enterprise, there are complex workflows that exist that touch your CRM and many other things. They have to come together. OpenFlow finally gives you a basis to bring AI to all of that, right? So it's going to transform the world's enterprises. But security has to be hardened, right? That has to happen for enterprises to adopt it. But I do think with what's going on with Claude and Codex and OpenFlow and Nvidia's NegoFlow, it's right for enterprises to transform it.
Open cloud security, that's what Yogesh mentioned. Okay, so Renu, looks like you need to take the last question.
Okay.
Probably the hardest.
Yeah, thank you, Karan. I feel like I'm gonna do her show, okay? But yes, go ahead.
Okay, so you have to just finish this in like one sentence. And my question is starting like the biggest mistake companies make when starting their AI journey.
They need to focus on making sure they have clean and accessible data. It all starts with data and a specific for the use case that they're targeting.
Wonderful, right? In the AI, everything starts from the data. So just to like quickly summarize, talked about 5 layers. Energy to chips, infrastructure, models, to the application. All these 5 layers are essential for making AI actually, going into the production. There's just so much work and so much focus is going in each and every layer. A lot of people think, hey, if you building just the chips or you building just the applications, that will go and create the full stack. No, we really need to go and do the innovation, do the work, do the collaborations at each and every layer. And like, we, this group, kind of given a little bit of like very selected points, some of the ideas, how we can go and think about each and every layer. So with that, I'm not sure how much time we have, organizers can tell us, but I'm happy to take 1 or 2 questions from the audience.
Thank you for the panel to share all your thoughts and ideas. My specific question is, and this be embedded AI, be very specific to industry verticals. Let's say, for example, Nvidia for retail, Nvidia for manufacturing, Nvidia for aerospace. Where do we go with that kind of ideas? Because the industry is so growing fast, and the enterprise means there are so many enterprises involved. Very specific Nvidia to verticals would be very helpful, I think.
I think if I paraphrase your question, I think you're asking there's other vertical specific AIs and go-to-market motions here that we need to put in place, given that AI is going to proliferate every part of the industry. Is that the right interpretation? Sure.
So first of all, let me answer this from an Nvidia standpoint. We are an accelerated computing platform company, but we go to market vertically because the business problem in each vertical is very, very different. And so in each vertical, we pick the 2 or 3 or 4 problems that are meaningful for us to go solve, right? So for example, if you take the payments industry, we may say, we're going to solve the problem of fraud detection in milliseconds, or we're going to solve the problem of personalization of offers, right, using transaction foundation model. So we are that specific about solving specific things in verticals.
At the end of the day, you need to solve the domain-specific problems, right? And that's super important, right? AI is a technology to solve those end problems. I think that's the way we always think about. I think there's a...
Thank you. So great inputs across the board, infrastructure, applied AI, physical AI. How do we differentiate against China? Because there's so much happening, are there some thoughts in terms of how can US stand out in the race?
How do we differentiate against China?
Is that the question? Okay. Okay, so I think it's not really about the differentiation. I think the best way to think about how we go and think about, I think Shilpa mentioned this point earlier, AI is like becoming kind of the next industrial revolution, kind of becoming such an important aspect in each and everything which we do. I think every country, every nation will have their way in terms of thinking. Like there is a lot of research happening in this space across the country, right? And how we can think about the best and efficient and the safe uses of this technology is super important.
Philip, I want to add something.
Yeah.
The way we think of China is China has roughly say 50% or more than 50% of the world's developers. And what they build, don't think of it as building just for China. They are building for the whole world. DeepSeek is not just for China, it's for the whole world. And so our focus is on enabling the developers of China. I know, so for example, we have to comply with US government and Chinese government, give them right compute, but we still want to give them whatever compute is allowable to us to enable those developers so that the world can benefit. So that's our mindset.
Okay, I think we are running out of the time. We will be here, so you guys can meet us after this session. But thank you very much for all my comments.
Thank you, Nvidia leaders. You just have an amazing perspective to everybody. And I appreciate your continued support. Thank you so much for bringing it all together. Over to Ria. And please don't go, we have Marissa Meyer and along with Margot Georgiadis, and also we do have Mariam Nafisi. So over to you.